Hi, this is Ms. White, and the second bonding video is about drawing Lewis structures. You should have your periodic table for this video. Drawing Lewis structures for neutral atoms is review from nomenclature, so we'll go over this fast. To draw the Lewis structure for a lithium atom, for example, has 1 valence electron, so 1 dot. Aluminum has 3 valence electrons, so 1, 2, 3 dots. Phosphorus has 5 valence electrons, 1, 2, 3, 4, 5, I double up. Oxygen has 6 valence electrons, so 1, 2, 3, 4, 5, 6, I double up. To draw Lewis structures for cations, we need to remove the dots because cations lose electrons. So the sodium neutral atom has 1 valence electrons. We draw the ion by removing that electron, and we draw a square bracket around sodium with a charge of +1. Calcium has 2 valence electrons in the neutral atom, so we remove those 2 dots, calcium with a square bracket and a charge of +2. Aluminum has 3 valence electrons in the neutral atom, so we draw aluminum with a square bracket, no more dots, and a charge of +3. To draw Lewis dot structures for anions, anions have gained electrons, so we have to add some extra electrons. The bromine neutral atom has 1, 2, 3, 4, 5, 6, 7 valence electron. It gains 1, so I add a cross to show the gained electrons, and then a square bracket and a charge of -1. For the sulfide ion, sulfur has 1, 2, 3, 4, 5, 6 valence electrons. It gains 2 electrons, so 2 crosses, square bracket, and a charge of -2. To draw Lewis structures for ionic compounds, we are going to first write the formula. So sodium chloride is NaCl. So we have 1 sodium ion, which has combined with 1 chloride ion. So when we draw it, we draw 1 sodium ion, Lewis structure, 1 chloride ion, 1, 2, 3, 4, 5, 6, 7 with a cross, and the square bracket, and we're done. Aluminum sulfide's formula is Al2S3. So we have combined 2 aluminum ions with 3 sulfide ions. And there we have aluminum sulfide. Drawing Lewis structures for covalent compounds, we have to remember a couple of things. We know the octet rule by now, which states that atoms are more stable when they have 8 electrons in their outer energy level. We have some exceptions to the octet rule. The first one is the incomplete octet, which includes atoms that cannot actually fit 8 electrons. So hydrogen can form bonds when it is surrounded by only 2 electrons. Beryllium, when covalently bonded, remember beryllium is a metal, but it can form covalent bonds. It tends to form bonds in which it is surrounded by 4 electrons. Boron and aluminum, when covalently bonded, tend to form bonds in which they are surrounded by 6 electrons. Then there is the expanded octet, which include atoms that can fit more than 8 electrons. These are nonmetals in periods 3 and up of the periodic table, starting with phosphorus. Let's look at a few symbols which we need to be familiar with. One pair of bonded electrons is represented by a single dash, and we can see this over here and over here. The bonds are in between 2 atoms in a molecule. These could also be represented by 2 dots, and we can see this here. A pair of electrons that is not shared, in other words, non-bonding, is represented by a pair of dots around the atom. We can see those here and here on the water molecules. These are also lone pairs of electrons. The central atom is the atom in the center, and a peripheral atom is an atom around the central atoms. A single covalent bond or a single bond is a bond in which a pair of electrons is shared between 2 atoms. And we can see some single bonds here between the oxygen and hydrogen and between the boron and chlorine atoms, for example. These are the rules for drawing Lewis structures for covalent compounds. I will not read over them with you. You need to pause the video, write them down, and have them handy as we practice. Let's practice. Carbon tetrachloride's formula is CCl4. To find out how many valence electrons are available in this molecule, we say that carbon has 4 valence electrons and there is 1 carbon in the formula. Then chlorine has 7 valence electrons and there are 4 chlorines in the formula. So I multiply that by 4 for a total of 32 valence electrons. So now I'm going to draw the formula. I'm going to pick carbon as my central atom according to the rules. And then I'm going to bond it to the 4 chlorine atoms. So 1, 2, 3, 4. Remember that each of these bonded lines represents 2 electrons. So I have used up 2, 4, 6, 8 of my available 32 electrons. Now I give an octet to all the peripheral atoms. Fluorine already has 2 in the bonded area. 3, 4, 5, 6, 7, 8. 2 in the bonded area. 3, 4, 5, 6, 7, 8. Notice that I'm putting the electrons in pairs every time. 2 in the bonded area. 3, 4, 5, 6, 7, 8. 2 in the bonded area. 3, 4, 5, 6, 7, 8. Now remember that when a bond forms, these atoms are sharing electrons. So now I check my central atom if it has an octet or not. And carbon is sharing with chlorine, so it has 2, 4, 6, 8. Now I have to check that I have used exactly 32 electrons in this structure. If I count the electrons around this chlorine and carbon here, I have 8. Over here, I also have 8. Over here, I also have 8. Remember that a dash is 2 electrons. And over here, I have 8. So I have used up exactly 32 electrons. So this is the correct structure for carbon tetrachloride. Let's try water. Water is H2O. So when I check my available valence electrons, hydrogen has 1 valence electron and we have 2 hydrogens. Oxygen has 6 valence electrons for a total of 8 electrons available. Then I draw my structure. Oxygen will be my central atom since there's only 1 of them. And I'm going to put the hydrogens on each side. Now remember that hydrogen can only have 2 electrons. So because of the bond here being 2 electrons, we already have satisfied hydrogen being stable. Then I have to give an octet to my oxygen, and I have 2, 4 electrons around the oxygen already. 5, 6, 7, 8. I add them on the central atom as lone pairs. So this is the correct structure for water. Sometimes atoms can share more than 1 pair of valence electrons to form double or triple bonds. A double bond is formed when atoms share 2 pairs of electrons. So the 2 oxygen here are sharing 2 pairs of electrons represented by 4 dots or by 2 dashes. A triple bond is formed when atoms share 3 pairs of electrons or 6 electrons. We have the 6 electrons shared here for nitrogen, which is a triple bond, or 3 dashes to represent our triple bond. Carbon, oxygen, nitrogen, and sulfur are the atoms that tend to form multiple bonds, and hydrogen and the halogens do not form multiple bonds. Let's practice double. Carbon dioxide's formula is CO2. Again, I count my available valence electrons. Carbon has 4, there is 1 carbon, plus oxygen has 6 valence electrons, 6 times 2 oxygens, for a total of 16 valence electrons available. So I'm going to put carbon in the middle, and I'm going to bond it to the 2 oxygen atoms on each side. Now I give 8 electrons to each oxygen to make it stable. So I have 2 in the shared area, 3, 4, 5, 6, 7, 8. 2 in the shared area, 3, 4, 5, 6, 7, 8. Now, if I count up how many electrons I've already used up doing that, I have 2, 4, 6, 8, 10, 12, 14, and 16. So I've already used up all the electrons I have available. But if I look at my central carbon atom, it is not satisfying the octet rule because I only have 4 electrons around this carbon atom. So now I have a problem because I can't just add electrons out of nowhere. They are not available. So that's when we form the double and the triple bonds. So forming a double bond means that I'm going to take a pair of electrons from one of the oxygens and switch them to the bonded area to form a double bond to help carbon satisfy its octet. Having done that, I can redraw it and go. Now I have a double bond here, and my oxygen has 2 lone pairs instead of 3. And I rewrite the oxygen on the other side like it was. Now I check again. This oxygen has 8 electrons. It's happy. 2, 4, 5, 6, 7, 8. The oxygen on the right has 2, 3, 4, 5, 6, 7, 8. So it's happy. But the carbon in the center still has 6 electrons. 2, 4, and 6 in those 3 bonds. So carbon is still not satisfied and not stable. So I'm going to take one more lone pair of electrons from oxygen and transfer it to the bonded area between carbon and oxygen. Now I can redraw my final structure. I will have a double bond here, and now this oxygen will only have 2 lone pairs, and I can redraw this one over here. Now if I count, I have 8 electrons around this oxygen, 8 electrons around this oxygen, and my central carbon atom also has 2, 4, 6, 8, and it is now stable. So this is the correct structure for carbon dioxide. Remember that there are some exceptions to the octet rule. Boron trifluoride is BF3. Valence electrons for boron is 3. And then for fluorine is 7, and I have 3 fluorine atoms, so we have 24. We are going to put boron in the middle, and we are going to single bond it to the 3 fluorine atoms. And that has used up 2, 4, 6 of our 24 available electrons. Now I give all the fluorines an octet. I've used up 6. 8, 10, 12, 14, 16, 18, 20, 22, 24. I have now used up all my 24 available electrons. And if we check for octets, we have 8 around this fluorine, 8 around this fluorine, and 8 around this fluorine. And boron has 6, which is stable for boron. So I did not add any extra electrons, and this is the correct structure for boron trifluoride. Now we're going to draw Lewis structures for polyatomic ions. Remember, they are covalently bonded molecules with a charge. So when we count the available electrons, we have to account for the gained and lost electrons in the ion. Positive charge means we have lost electrons, and a negative charge means that we have gained electrons. So let's go and practice. The chloride ion's formula is ClO2, the -1 charge. We count the available electrons. Chlorine is 7 and oxygen is 6, and we have 2 oxygens. But now we have to account for this negative charge. So because it is negative, it has gained an electron, so we add that gained electron. We'll put chlorine in the middle since there's only one of the chlorines, and I'm going to put 2 oxygens on each side. Then I'm going to give each oxygen an octet. I have already used 4 of the available 20 electrons. So 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. I still have 4 electrons available, so I'm going to put those as lone pairs on the central atom. 17, 18, 19, 20. Now to show that it's an ion, I have to put the whole structure in a square bracket and put the charge. Let's make sure that the octet rule is satisfied. We have 8 electrons around the left oxygen, we have 8 around the central chlorine, and we have 8 around the right-hand side oxygen. So we are done. This concludes our bonding number 2 video over Lewis structures. You should have taken high quality notes and rewatch this video as needed and ask questions in class.